Hey guys, welcome to your algebra lesson on simplifying radical expressions. So for exercise 1, we need to find the value of each of the following principal square roots. Now, principal square roots means that you're only looking for the positive answers. And normally, when we take the square root of something, we end up with a positive or negative version of that thing. So for the first part, we're just focusing on positive principal square roots. And we're going to write a reason for your answer in terms of multiplication equation. So here's how that's going to look. The square root of 25, as you know, is 5. And when you write a reason for your answer using multiplication, you're going to say the reason that works is that 5 times 5 is 25. So if you want to pause the video now and go through these before I give the answer, you can, or you can just follow along with me. Part B says the square root of 9. We know that is 3. And the reason is that 3 times 3 equals 9. The square root of 100 is 10, and that's because 10 times 10 equals 100. And as we keep on going, the square root of 0 is 0. And obviously, 0 times 0 is 0. When we move on to fractions, when you take the square root of a fraction, one thing that you can focus on is taking the square root of each part. So the square root of 1 is 1, and the square root of 4 is 2, so the square root of 1/4 would be 1/2. And we can show that 1/2 times 1/2 is equal to 1/4. And again, we have another fraction. We know that the square root of 64 is 8 because you ate and ate and got sick on the floor. And the square root of 9 is 3. So our answer would be, in fraction form, 8/3. And 8/3 times 8/3 is 64/9. Now, it's also important to understand that the square root of a times the square root of b is also equal to the square root of a times b. So this might make more sense with actual numbers. If we said the square root of 4, and we multiplied that with the square root of, let's just do 9, right? That should equal the square root of 4 times 9. Now let's see if it does. The square root of 4 is, I'm going to write it over here because I'm running out of room, 2. The square root of 9 is 3, and that should give me 6. And if we focus on the other side, the square root of 4 times 9 would be the square root of 4 times 9 would be 36. And when we take the square root of 36, we get 6. So that shows that we can write it broken up, like the square root of something times the square root of something else, or we can write it together as one big square root. And the two are equivalent. Okay, this is awkward. I guess I should have looked ahead. A and B are literally the same exact problems I did just ahead. So we'll still do it here, I guess. The square root of 4 is 2. The square root of 9 is 3. 2 times 3 is 6. The square root of 4 times 9 would be the same thing as the square root of 36, which, again, gives us 6. C and D are very similar. So when we take the square root of 4, we get 2. The square root of 25 is 5. 2 times 5 is 10. When we do the square root of 4 times 25, it would be 4 times 25 should be 100. The square root of 100 is 10. And we see here that both answers are the same. Now, to list out the first 10 perfect squares, starting with 1, I'm hoping that you have these memorized, so I would prefer if you would pause the video now and write all of the perfect squares from 1 up to 100 without seeing the answers first. So go ahead and pause the video now. And here are your perfect squares. Now, we consider the square root of 18, which is the perfect squares. It says which of the perfect squares listed above is a factor of 18. Now, it's important that you remember that factor means two things that can multiply together to give you a desired result. So the question is, what are your factors of 18? So let's figure that out first. So obviously we always start with 1. So 1 and 18, 2 and 9, 3 and 6. And those would be all of the factors. So what you need to figure out is you always focus on the largest perfect square of those factors. And in this scenario, 9 would be the largest perfect square. So it says which of the perfect squares listed above is a factor of 18. Well, 1 is also a perfect square, but 9 is the one that we're focusing on because 1 will always work. Now, simplify the square root of 18 in simplest radical form. And this is what we're focusing on today. So this is the new part. Well, if 9 and 2 are factors of 18, right, then if we're focusing on the square root of 18, then the square root of 18 can be broken up by the square root of 9 times the square root of 2. And the way that we can simplify this even further is we focus on the perfect square, which we know is 9, and then we say, well, what is the square root of 9? Well, the square root of 9 is going to be 3, so this is going to turn into 3 radical 2, and that is going to be how I can simplify the square root of 18. Don't worry, we'll practice some more so that we can all get the hang of it. Below, we have write each of the following square roots in simplest radical form. So we start with the square root of 8. If we figure out what two numbers go into 8, where one of them has to be a perfect square, hopefully we can figure out that it would be the square root of 4 and the square root of 2. Now, of those perfect squares, 4 would be the only perfect square that we're going to use, and the square root of 4 is 2. So then we just have to bring down what we have left, and what we have left is the square root of 2. So our answer for how we can simplify the square root of 8 is 2 radical 2. Let's try it with the square root of 45. Go ahead and list all of the factors of 45 until you can figure out what perfect square goes into 45. So you might want to pause the video now so that you can think about it. And hopefully that you figured out that 9 would be the perfect square that goes into 45, and the square root of 9 is going to be 3. And then we just bring the radical 5 because we can't simplify radical 5 any further, right? There's no perfect square aside from 1, which won't do anything, that will go into 5. So 3 radical 5 is our final answer. Now we have the square root of 48, And I would also like you to pause the video now to figure out all of the factors of 48 because there are a few perfect squares that go into 48, but we always want to choose the largest one. So here are all my factors of 48, the square root of 48, and if I look here, 1 is a perfect square, but again, just disregard 1 for the time being. And the next perfect square that I see is 16. I also have the perfect square of 4. But because 16 is the largest, I'm going to use that combination. So the square root of 16 is 4, so that gets written first. And then the radical 3 can't be simplified, so that just gets written right next to it, and there is my answer. Okay, this next part is definitely my favorite, so bear with me because it might sound a little weird. But when we simplify odd exponents under the radical, okay, so when you start dealing with exponents, this is what I want you to focus on. We're going to consider this club radical, and club radical is in a rather bad neighborhood, so you can only leave the club in couples or groups of 2. Couples leave the club and stand outside, while singles go back in until they find a date. So here's how this is going to work. If we focus on A, which says the square root of x cubed, right? If I write how many x's I have, I will have, there's 1, 2, 3 x's. You have to figure out, and it helps sometimes if you put up fingers, so right now I'm holding up 3 fingers, not that you can tell, but you have to figure out how many couples can you make out of a group of 3. And I'm hoping you understand that you can only make 1 couple. So this right here is a couple. And we only have 1 single left. So the couple, there's 1 couple. They get pulled outside of club radical as x, and the 1 single, this little guy, has to go back inside club radical until they find someone to leave with. So our answer, as weird as it might look, is x radical x. Let's try it again with this time numbers. So in part B, first we talk about the square root of 72. So as you list the factors of 72, right, you've got 1 and 72. Since it's the even number, 2 will also work. So 2 will go in with 36. And if we keep on going, and we have the square root of 3 and the square root of 24, and 4 should also work. So 4 and 18, gonna run out of space here. And then we've got, well, 5 won't work, but 6 should. 6 and 12. 7 doesn't work, but 8 will. 8 and 9. And I know that my next term would be 9, and I've already used 9, so once I start repeating, I know that I've got all my factors. Okay, so this is a rather big list, but if we look at our list, we'll notice that the largest perfect square is 36, so that's going to be the combination I want to use. So the square root of 36 is 6. I'm going to leave a little bit of space to deal with my x's before I put the square root, and then I have to bring the radical 2 along. Now, I might have to erase a little bit of this so that I can make room for what I have to write in the radical as well. Now let's deal with the x's, right? If it's helpful, you can draw out 7 x's, so I can do that now. 2, 3, 4, 5, 6, 7. Okay. Now you don't have to do this in the future. You can use your fingers or just your mind. But if you figure out how many couples can you make with 7 people, we've got 1 couple, 2 couples, 3 couples, and 1 single left. So the 3 couples get taken out of club radical as x to the 3rd, the 3 representing the 3 couples. And then inside the radical is the 1 single. So our final answer is going to say 6x cubed radical 2x. Okay, part C is a little bit different because now we have a number that's in front of the radical symbol. And what that number does is it multiplies with whatever we pull out of the radical. So before I forget, I'm just going to write down that -3 here because that is going to multiply with whatever I take out of the radical so that I don't forget it. Okay, so now let's break down the square root of 75 into all of the factors that we can come up with. So if you want to pause the video now, you can, to figure out all of the factors for yourself. Okay, this should be all the factors that I need. And if we look at this list, the largest perfect square is 25. So the square root of 25 is 5. So that 5 gets taken out of the radical, and the only thing left is the square root of 3. Now, this answer looks strange because it's not quite simplified. So when I multiply -3 and 5 together, I get -15, and then I still have the square root of 3, and that's my final answer. Okay, part D starts us off with there's a number out in front of the radical, so again, before we forget about it, we're just going to bring it down, put it in parentheses so we remember to multiply it with whatever number we take out. Then we'll go ahead and we're going to list all of the factors of radical 20 until we come up with the largest perfect square that's going to go into radical 20. And this is why it is important that you know and recognize your perfect squares to make this process much more seamless. So, of my factors of 20, the largest perfect square would be 4. So the square root of 4 is going to give me 2. So I'm going to have a 2 taken out, leave a little bit of space because I have some x's to deal with, and then I still have radical 5 in there. Now for the x's. If you want, you can draw out all of your x's, so you've got 9, or just hold up 9 fingers. So when you hold up 9 fingers, start to group your fingers together into pairs of 2, right? And you'll notice that you should have 4 groups of 2, 4 couples. Because you have 4 couples, you can take out x to the 4th to represent 4 couples, and you have 1 single left that has to go back inside club radical. Now when we clean this up a bit, when you multiply what's on the outer part of the radical, you're going to get 4 x to the 4th, and the radical stays the same, square root of 5x. And that is your answer. Okay, moving on to part E. Part E has 2x that's in front of the radical, so we're going to bring it down so that we don't forget to multiply it. And then we break down the square root of 8, and this won't take very long because there's not too many factors of 8. And we'll figure out that the largest perfect square should be 4, and the square root of 4 is 2. Leave a little space to deal with our x's. We still have to remember that the square root of 2 needs to show up. And this time we have 8 people. Think of them as people. 8 people go into the club. How many couples are allowed to leave this club radical? And since 8 is an even number, all couples can come out, and there should be 4 couples that can leave the club and no singles remaining, which is why there are no x's left inside the radical. Now, when we clean this up a bit, and we multiply the outer terms together, 2 times 2 is 4, and remember that we add exponents together when we multiply. So, That should give me x to the 5th. And then I still have the square root of 2 that I can't forget to write down. So my final answer is 4x to the 5th radical 2. Okay, last one. So part F says the square root of 16 over 9. Now remember, with fractions, treat them as their own separate entities. So the square root of 16 is 4. The square root of 9 is 3. Because those are perfect squares, it gets removed from the radical completely. Now if we deal with the exponents. For the x group, there are 4 people in this group. How many couples can you make? And hopefully you figure out that you can make 2 couples. There are no singles left over, in that x group at least. For the y group, there are 3 people in this y group. You can make 1 couple, so that 1 couple comes out, and because there is 1 single, that 1 y single has to go back inside club radical. And now we have our final answer. And that concludes our notes.